Hello, everyone, and welcome to this class. Today we will be finishing last lecture, which was about solving inequalities with a sign chart, and then we'll start our unit on geometry. All right. So this class will be an introduction to Euclidean geometry. Hopefully we get to that. But first, let's do some review on inequalities because we didn't finish that last time. So can anybody solve this inequality for me? And you're going to use the sign chart on this one. You're going to use the sign chart. Remember, it's been like 2 weeks since last lecture, but hopefully you took notes. So this should not be too hard. Just use the sign chart to solve this inequality. All right, I'll give you a few moments to solve this, and then I'll go over it. All right, are there any answers? Does anybody know how to solve this? Are there any answers? I'll give you a few more moments to solve this. Okay. Hopefully you can have some answers by then. All right. So negative infinity to -2 union 3 to infinity. Except you change your answer, -2 to 3. And your second answer is correct. Very good job. Whoever this is, blank. Very good job, blank. Oh well. Okay, so how do we solve this? We exclude the zeros first. So what we need to do is we need to draw a number line. Draw your number line. Okay, and we're going to find the intervals. So what causes the zero? By the zero product property, if something is equal to 0, if AB equals 0, either A equals 0 or B equals 0. So for x minus 3 to equal 0, x cannot be 3. For x plus 2 to equal 0, x cannot be -2. So our intervals are -2 and 3. So these are the intervals in which x does not equal 0. So using our sign chart, let's solve this problem. So what you need to do is you need to write your intervals on the top. All right. And then, okay, you write your factors on the side. And you're going to figure out when x is positive and negative, right? Because you want this to be, when you're multiplying these factors together, they need to be less than 0, and you'll understand later once we do this. So when x minus 3 is positive, oh, what does that mean for x? Okay, x must be greater than 3. Right, so this is negative. Okay, hold on. Let me write x plus 2 first. So when is x plus 2 positive? Well, that's when x is greater than -2. So now let's go back to our problem here. So for x minus 3, the interval negative infinity to negative 2, x is not greater than 3 there, so this is negative. This is also negative, but this interval is positive. For x plus 2, it's negative, positive, positive. So you see the result when you multiply these two factors together. Well, you get positive on this one, negative and positive, and we want negative. So the answer for this one, right? The solution for this one would be negative 2 to 3. All right, and we're not going to use square brackets for this one because it is strictly less than 0. Right, so we're using parentheses, which means that negative 2 and 3 are not included. All right, does everybody get this strategy? All right. And if you're just arriving, you're a bit late, so you missed some of this, but we'll be going through a bit more problems using this. So let's go through this one. How are you going to solve this problem? All right, I'll give you a few more moments to solve this. And the key to this is factoring. The key to solving these inequalities is factoring. Once you factor, then you can find the zeros, exclude the zeros, and use the sign chart. So the key here is to factor. All right. So I'll give you a few more moments to solve this. And you must use the sign chart method that I taught you last lecture. All right, that's the most efficient way to solve these. All right, and the key step is to factor. Without factoring, you can't use the sign chart method. So if you have any questions or you don't know how to do it, please wait till I go through this problem. But if you do know how to do it, please post your answer in the chat. All right. What do you mean no? Oh well. Okay. Does anybody have any answers? Oh, you don't get the last problem. How? Okay, so I assume you weren't here last lecture. So the last problem. Actually, let me walk you through this one, and hopefully you'll understand. So the key thing about this is to kind of understand the zero product property. So the zero product property states that if AB equals 0, then A equals 0 or B equals 0. All right. So let's put that to the side and let's factor this first. I assume you know how to factor. That's quite basic algebra. So let's factor first. Let's use our X method to factor. That's quite a fast way to factor. So basically, let's see, 1, 2, negative 1, and 5. Okay, that works perfectly. So x minus 1 and 2x plus 5. So that is how we factor that. Okay, so, and that is greater than or equal to 0. All right, so after we factored, we need to find where x equals 0 because we want to exclude those zeros. Maybe not necessarily exclude them later, but we need to find those when x minus 1 times 2x plus 5 equals 0. Right. So when does x minus 1 equal 0? Well, that x minus 1 equals 0 when x equals 1. Right, so exclude that 1. So when does 2x plus 5 equals 0? It's negative 5 over 2. Hold on. And negative, oh, I made errors here. Negative 5 over 2 and 1. We need to exclude those two values. All right, because those are our zeros. Now we can use our sign chart. So this is the sign chart method, in case you haven't been to the last lecture. So the sign chart, basically, let's do it first, all right? So the intervals that exclude the zeros are, these are the zeros, right? These are the zeros. We're going to exclude them. So we're only going to find the intervals between these zeros. So it's negative infinity to negative 5 over half, not including that, and then 5 halves to 1, and 1 to infinity. All right. And then x minus 1, 2x plus 5, right? Those are our factors. So when is x minus 1 positive? Well, you see here, x minus 1 is only positive over here. X minus 1 is positive over here, right? Because x has to be greater than 1 to be positive, right? So when does 2x plus 5, when is that positive? Let's use another color to highlight that. When is that positive? Well, you kind of have to solve the inequality. So let's solve it, all right? X is positive only when it is greater than negative 5 halves, right? And that's here. Okay? So you see the intervals now, right? You see the intervals now. So let's solve. Okay, so where was that? Oh, well. Is this the, nope, this is not it. I'm having issues about this one. This is, this looks weird. Oh, well, let me just use this one. Okay, so, nope. Hold on, I'm trying to find the correct pencil. Oh, well, let's just use this one. So, when is x minus 1 positive? Well, it's negative here, and positive here. And when 2x plus 5 is positive in this interval, and these two intervals, and negative here. And since you're multiplying them together, since they're both negative in this interval, right? They're both negative in this interval. Negative times a negative is positive, right? So this is positive, and we want positive because we want it to be greater than or equal to 0. All right, and then this is negative and this is positive. All right, so these are our two solutions. So negative infinity to negative 5 halves, right? We use square brackets there because it's greater than or equal to union 1 to infinity. All right, so are there any questions on this? That is our solution here. Are there any questions? Okay. So yes, x is part of the negative infinity to negative. Oh, you made some errors. It's negative 5 halves instead of negative 2 5/5. All right. So make sure you don't make some small mistakes like that. Okay, yeah. And also, I'm not sure if you would use the mathematical symbol. You see here you used X is part of this. All right. I'm not sure. I'm not totally sure, but I don't think you would use this mathematical symbol. This part of here, because usually this means part of the set, part of a set, and this isn't really a set. It's just two intervals. Right. So I'm not sure. Maybe I'm wrong. Google it. But I really hadn't thought about that. So since I'm not sure, just write the solution. Because usually, let's say X is part of the set of real numbers. All right, that is possible because real numbers, that's a set of real numbers. All right, or maybe a set of part of the set of irrational numbers. All right, okay, those are all sets. You can be part of that set, but for these intervals, I'm not so sure. So maybe Google that in your spare time. So let's only do one of these. Let's do number 3, and then let's move on. If we have time, let's go back and do the 4th one. But I don't think we have that much time. So let's do this one. All right, I'll give you a few moments to solve this. This is a bit harder. All right, this is a bit harder. So make sure you do not make mistakes on this one. All right. Make sure to check your answer. Okay, I'll give you a few moments to solve, and I'll check back later. All right. And if you do know the answer, please put it in chat. All right. So there are no answers yet, so I'm assuming you need more time. So all right, I'll give you a bit more time. Again, if you don't understand, you can wait till I explain it. And also, Eva or Ava, I don't know if it's Ava or Eva, but sorry if I mispronounce it. But if you don't understand the sign charts, you can go on YouTube and watch my YouTube video. I updated all the videos of all the classes. So if you don't understand this, you can watch the video of last lecture, which I think was the weekend before Labor Day weekend. All right. Oh, the name is just my name, Tianle Liang. All right. Just go search up my name on YouTube, and the videos should pop up. Okay. Yes. So but we won't be doing these inequalities for long. So you can watch the videos in your spare time, because I want to get to our today's topic, which is Euclidean geometry. So, and that is, since the introduction is pretty easy to understand. So please stay for that. That's pretty important as well. But you know that Euclidean geometry, of course, it's going to be quite hard once you progress. So make sure to take a lot of notes during this geometry unit. All right. So let's see what you got. Here's the answer. You got -2 to -1, and union 3 to infinity. That's correct. Great job. Great job. All right. So how do we do this? Let's exclude the zeros first. All right. Let's exclude the zeros. So how do we do this? What are the zeros here? All right, we got -2, we got -1, all right? And then we have what? We have 1, just 1, and we have 3, right? We have 3. Okay, hold on. All right, those are all our zeros. So now let's find the intervals. Okay, and there's going to be a lot of intervals since there's 4 zeros excluded. All right, so let's make our sign chart. Make sure to make it big on this one. Okay, so it's -infinity to -2, -2 to -1, -1 to 1, 1 to 3, and 3 to infinity. All right. So once you have those 5 intervals, let's list all of our factors. So x plus 2 and 3 minus x and x plus 1. Now what about x minus 1 squared? That's one of the big things about why I put it here. Okay, so what about x minus 1 squared? What about it? Do you need to put it here? Do you need to put it in the factors part? Is it important to put it in the factors part, or do we not need it at all? Right? Okay, so do we need the x minus 1 squared? Do we need it? Actually, we don't, right? Yes, very, very good. Because it's not going to, yes. You're going to have to exclude 1, yes. That's very good, very good. Okay, so it's very good that you understand that, because it's always going to be positive, right? Because anything squared, then just automatically positive, all right? But we still need to exclude 1. That's great. Why? Because if we have 1 as x minus 1 as x, then 1 minus 1, that equals 0, and then the bottom will be 0, which means it's undefined, right? So that's why we still have to remember to exclude 1. That's why I included this 1 over here. All right, so now let's solve our inequalities. What is x plus 2 positive? All right, it's negative when it's less than -2, so positive when it's greater than -2. So let's just fill that in real quick. All right, so this, when is 3 minus x positive? Well, it needs to be less than 3, right? So far so good. And now this is negative. Okay, so now about x minus 1, easy, right? It has to be greater than -1. All right, so now let's solve. Can anybody tell me whether this side, is it negative or positive? All right, I want everybody to participate on this one. It's not too hard. Is this negative or positive? All right, when you multiply it together. Is it negative or positive? All right, please post in the chat. Is it negative or positive? It's positive? All right, Jason says it's positive. All right. And blank says it's negative, and Ava says it's positive. All right, how do we know this? The answer is it's actually negative. It's negative. Why? Because we have positive times a positive, all right? Positive times a positive, but that does not mean it's positive, right? Because positive, it's trivial, right? Positive, it's kind of trivial, you know? Because positive really doesn't change anything. It's a negative that changes. So if you multiply these two positives together, you still get a positive. However, a positive times negative, that you get a negative. All right, so this is a negative. So now let's work on our intervals. So the solution to this would be -2 to -1, but not including -1, because here, if you get -1 as x, then the denominator of this fraction would be undefined, right? Because it's over 0, and that's undefined right now, and until we get to calculus, which is going to be a long time. So, and then we're going to union that with the other interval, all right, which is 3 to infinity. Now, since it's less than or equal to 0, we can have 3, right? Because it's on the numerator, it doesn't matter. If you have 3 as x, then that means the numerator is 0. But since it can be less than or equal to 0, then we can include 3. So 3 to infinity, not included. And of course, infinity is always not included, right? Since it's an intangible thing, all right? You don't know the end of infinity, so you just can't include it. All right, so yeah. All right. So I hope everybody understands this concept of using the sign chart to solve. All right. And the big thing to take away from this problem is to make sure that your denominator is not undefined. And if you ever see this squared, remember to still exclude the 0, but you don't have to add it as a factor because it's always positive. Now, let me give you a problem. What if you were to add a -2 here? If you were to add a -2 on the numerator, would you have to add the -2 as a factor? Can anybody answer this? If you had a -2 on the numerator, multiplying everything, would you have to add it as a factor? No, just switch the sign of the inequality. All right, yes, you could do that, possibly. Oh, yes, you could do that. You could do that. But I think it's easier. Actually, your way is actually quite easy as well, but you could also add it as a factor because it's always negative, right? Negative, 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 right? That would turn these two into negative, this into positive, and this into negative, all right? So if you ever see a negative number like that, either change the sign like blank said, or you can add it as a factor since it's always negative, all right? It's going to change the inequality, unlike a positive number. Now, if this were like 2, just 2, that wouldn't change anything, right? You don't have to add it as a factor. So, let's move on to our next unit, which is Euclidean geometry. All right. So everybody take out your notes. We're going to be learning some geometry now. All right. So, first, are there any questions about that? Okay, so how are we going to draw? It doesn't matter. All right. We're not really going to draw. All right. We're going to express. I'm going to draw, actually, which will probably not be a good idea because I suck at drawing, but it's going to be good. It's going to be good. But you're not going to have to draw. Okay, you'll see what I mean later. So let's move on to Euclidean geometry. So you see here, Euclid, the person who invented Euclidean geometry, or he was most commonly known as like the father of geometry, right? And he's not really the father of geometry because they, mathematical concepts, they just exist, right? no one really knows who created them, but he was credited with a lot of great ideas, great ideas in geometry. That's why we call him the father of geometry, I guess. So, without Euclidean geometry, let's say you had a point, P to Q, right? You had a point P here and Q here. All right, you had a point PQ. Okay. So before Euclidean geometry was really invented, or Euclid started using this method, what would you have to do to know the measure of PQ, right? You have to measure it, right? You have to measure it. So be the absolute value of PQ. That is the measure of PQ. But after Euclid decided to come along and create some great concepts, well, he created like how to graph a point on this coordinate plane through a set of two coordinates, right? Right, like x and y. And through x and y, you can create a new point, P. All right. And P is the point of which x and y graph, right? So this is what he created, a point. And that changed a lot of things. First, you can now find the distance between 2 points very easily. You can also find midpoints. There's tons of new stuff you can do with this, right? So that is our introduction to Euclidean geometry. So these are some two basic concepts of how of what we work with coordinate geometry, all right? So the distance between 2 points, the distance, okay, d of A to B, this is denoted as here, no, as shown here. So how would you use this? So if you wanted to find the distance between 2 points, all you need to do was to use this formula. All right. So let's draw our coordinate plane here. If you're taking notes, which you should be doing, please draw a coordinate plane with me. All right. So let's say we have two points here. We have 2 points here, and let's call them A and B. All right. And the distance between them, that is D. All right. So how would we find the distance between them? Well, you can use the Pythagorean theorem. All right. The Pythagorean theorem you can use a lot in coordinate geometry. So you see here, the slope here, it can be the hypotenuse of a right triangle. All right. And all you need to do, you just use the Pythagorean theorem. And from the Pythagorean theorem, we can get this distance formula. All right, so let's say that A is x1 and y1, all right? And B is x2 and y2, all right? So to get the height of this triangle, of this right triangle, and we need to use the Pythagorean theorem, we need to know these heights and lengths, okay? We need to find the height of this. So basically what we do is just y2 minus y1, right? To get the height of this triangle. Now for the length, same idea, x2 minus x1. And by the Pythagorean theorem, which states that a squared plus b squared equals c squared, which means that if we're trying to get the c squared right here, we need to take a squared plus b squared and we're going to square root that. And hence, we get this distance formula. One leg of the triangle squared plus the other leg of the triangle squared, square rooted, that's the other side. Right, that's the other side, which is the distance between the 2 points. And because Euclid found out how to make points on this coordinate graph, any distance between 2 points makes a perfect right triangle that you can use the Pythagorean theorem on. So that is why this distance formula is so important. All right. So does everybody get what I? Yes, I know that's someone else invented the plane, but Euclid really I think he took these points and he made really made use of this. Okay, he created this. You can use this distance formula, right? Pretty sure it's Euclid, I think. Anyways, he was called the father of geometry, so I assume he did a lot of good things, I think. I'm not so sure. This is sad. Oh, yes, and use the restroom. Okay, so now we haven't really done anything yet, but you'll get to do some in a couple minutes. All right. So let's first look at more midpoints. Oh well. So let's say you have A to B. So let's draw another coordinate plane. All right, let's draw another coordinate plane. So wow, okay, that is off scale. Okay, let's not do that. I hate this. Why? Why does it keep bending my line? I'm sure I'm not doing this. There's the... What? You gotta be kidding. Now I gotta move to a different location. Okay, so draw our coordinate plane. So let's say we have two points, A and B. Right? We have A and B. So, hold on. Let me draw a picture real quick. Now we have A and B. Okay, so points A and B, their x's, their respective x values, x1, x and x2. So the x value for the midpoint would be x, all right? So how do we find the midpoint of a segment? If you find the midpoint of a segment, you just have to divide by 2, right? However, what if you're given only like coordinate? We're just given points, all right? How to find the midpoint of the segment that those points create. So what we need to do is we need to use similar triangles. Oh, I'm sure most of you know how to use similar triangles, right? We're gonna use similar triangles. Okay? So we're gonna observe this, right? Okay, let's say this is P and Q. We need 2 more points. Okay, so observe that triangle AMP is similar to triangle ABQ. Right, observe that because this is a midpoint, right? It creates two congruent segments. All right, so that's how we get these two similar triangles. Now, by these two similar triangles, we get that 1/2 equals segment AM over segment AB because they're similar, right? And this is a midpoint, which creates two congruent segments. All right. And 1/2 is also equal to AP to AQ, right? And what is AP to AQ? Oh, what is that? That is actually x minus x1 over x2 minus x1, right? So basically, x, what would that equal? That's basically equal to x2 plus x1 over 2. All right, so that's how we get the midpoint of x. Now the y can be obtained similar. So basically y2 plus y1 over 2. Okay. So, are there any questions? No questions, then let's do some practice problems. So, let's say we had, let's give this a very easy example. So, if 3, 0, 2, find the midpoint of 3, 0, and 5, 0, all right? So, let's use this. Okay, let's use this. Find our midpoint, right? We can get the x values by adding our midpoint is basically 3 plus 5 over 2 and 0 plus 0 over 2, right? Okay, and we get 4 over 0, and that is our midpoint, right? So yeah, that's proof that this formula works for midpoints when we're giving two coordinate points. Of course, if you had a segment, you could just divide it in half, right? But this is when you get two coordinate points, right? So let's go through some examples, right? Number 1, show that triangle ABC is a right triangle where A is -1, -3, B is 6, 1, and C is 2, -5. All right. Show ABC is a right triangle. So how are we going to do this? I'll give you a few moments to think and possibly give me the answer. Well, not really an answer because you're just showing me. All right, so give some reasoning. Give some logical mathematical reasoning on why ABC could be a right triangle. All right, are there any questions? All right, prove that the lengths obey the Pythagorean theorem, then the triangle is a right triangle. And because the Pythagorean converse is true. That's a very good answer. All right. So basically, how we do this is we need to we need to prove that AB plus BC equals BC, or the other way around. Well, I haven't really graphed the points yet, but if you graph the points, you can see. Oh, no. Okay, that's a coordinate graph. All right, so you graph these points, -1, 1, 2, 3, 4, 5, 6. Okay. Oh wait, I made mistakes. Here, this should be the triangle. So you get a triangle like this. Okay, that's your triangle. So how do we prove this? Okay, how do we prove this? Well, basically, A is right here, C and B. So you see here, AC squared plus BC squared should equal AB squared in order to make it a right triangle. So basically what you have to do is you need to use the distance formula to find AC, and you need to use the distance formula again to find BC, and then square both of them, basically just getting rid of the square root sign, and see if it fits the Pythagorean theorem. So I'm going to save you the trouble here, and we're not going to do other work because I'm sure you know how to use the distance formula, and we're running out of time here. So, in fact, if you actually solve this problem, yes, this is a right triangle. This is a right triangle. Okay, so let's move on to another problem. We don't have much time here. So, suppose A is -1, -3 again, and B is 6, 1. Now find the equation of the perpendicular bisector of AB. So how to find the perpendicular bisector? So let's see. So if you use last problem, we know it's kind of like this, right? AB, okay? So in the perpendicular bisector, we come along right about here, the perpendicular bisector, okay? And this is point P. All right, so what we need to do is we just need to make a triangle, right? Well, the equation of the perpendicular bisector, we just need to find the point P. Okay? So, we need to prove that the distance from A to P is equal to the distance from P to B. Okay? So, we're going to set up equation, right? Because P is x, y. All right, so basically what we need to do here is all we need to do is we need to find x1, x2 minus x1, right, plus y2 minus y1 squared. All right, we don't need the square root because they both cancel out. So let's actually just write that. X plus 1 squared plus y plus 3 squared, right? Equals, what is the other side? P to B, right? X minus 1 squared? No, x minus 6. K squared plus y minus 1 squared, all right? So, simplify this. Okay, x squared plus 2x plus 1 plus y squared plus 6y plus 9 equals x squared minus 12x plus 36, right? Plus y squared minus 2y plus 1. Right, kind of ran out of space there, but once you get rid of everything, you can cancel out. Okay, and what else cancels out? Cancel out. Okay, also canceled out and canceled out. All right, so once you cancel everything out and you subtract everything, you see you get 14x plus 8y equals 27, and that is the equation of the perpendicular bisector of the segment AB. All right, so that's how you do this problem. Okay. Okay, yes, and you could use point slope theorem. I guess you could. Wait. So if you were to find the point slope theorem, then you would have to find, basically you're going to have to say the equation of the line PB is equal to the equation of the line PA. I guess that could work, kind of. You just need to find the slope, and it's going to be more troublesome, right? If you use these slope formulas, so let's not use that. Okay. There's a much easier method, which is just to set them equal to each other, but we will be working on point slope theorems and general form, slope intercept form. But it won't be similar to your normal algebra 1 class. Okay. We'll use it, explain why it works, all right? So that'll be the end of our class today. So if there are no questions, then thank you for listening, everyone, and I'll see you next time. Okay, bye.